factorising and solving quadratic equations. So the first two, what we've got to do here is we've got to find two numbers that multiply to make 6 and add to make 5. So those two numbers are 3 and 2. So we put those in our brackets, and 3 and 2, those brackets have got to be equal to 0. So then what we do is we solve our two scenarios. Either x plus 3 is equal to 0, or x plus 2 is equal to 0. And if we rearrange this, plus 3 becomes minus 3, and 2 becomes minus 2. And there's my two answers to my quadratic. The second one, we're looking for two numbers that multiply to make minus 35 and add to make minus 2. So they're going to be different signs. The two numbers are 5 and 7, but the signs would need to be minus 7 and plus 5 in order to give us a sum of minus 2. So when we put these equal to 0, what we have is two potential answers. One is y equals 7, the other y equals minus 5. So those are our first two. Now here is a more difficult one. This is your higher tier standard one. Now what I would do is I would multiply these two. So 3 times 10 equals 30. So I am looking for two numbers that multiply to make 30 and add to make 17. Now those two numbers are 15 and 2. So when I rewrite this question, I'm going to rewrite it with 15x and 2x in the middle of this quadratic. So I then factorize this in two parts. So I'll divide the first two terms by 3x. What do I need to put inside to give me 3x squared plus 15x? Well, I need x plus 5. The second part of this, I would take 2 outside of the bracket as a common factor. When I divide everything by 2, I get x plus 5 again. And then my values in front of each bracket, they go together to make one of the brackets, and the x plus 5 is the other bracket. And I put those equal to 0. So then one answer can be gained from having 3x plus 2 equals 0. The other answer from x plus 5 equals 0. The right-hand answer is slightly easier to work out. A plus 5 becomes minus 5. And the left-hand answer, 3x would equal to minus 2. And then x would be equal to minus 2 thirds. And there are the solutions to all those quadratics.